Oh, do I have 2,000? So there's what's left after I take the amount of load presented by the footer. There's what's left to be carried by the footer itself. Okay, we did that. So we got sigma net. That's letter C. Letter D, the above gives you the usable soil bearing capacity available for the remaining loads. Letter E, the width. The width of the footer, it's actually area, but we're designing 1 foot into the board. Okay, so this footer is W wide, 1 foot into the board. So the area is W, and it's also the width. So W is equal to the load we've got to carry. Here's what we've got to carry. Live and dead, 5,000 plus 7,000 divided by sigma net. So if I take and add 5 and 7, I get 12,000. So 12,000 divided by 1775 gives me 6.76. On a test, I'm going to make that increments of half of a foot. So you're going to be either 6 foot, 6 foot 6, 7 foot, 7 foot 6, or so on. This one, I'm going to make it to the nearest foot above, so we're going to use 7 foot wide. So my W is 7 feet. So I come over here, and I'm going to put 7 feet, but I'm going to also put it the way I want it, 84 inches. So I got a 7 foot wide footer. It's 18 inches thick. On it is a wall that's 10 inches wide. Okay, so we've got dirt pretty well whipped. Now, letter F, it says round to the width to the nearest 3-inch increment, so that's what I did. If you want to calculate letter G, be my guest. It's a check, not needed. You don't need to do it, but this is letter F right here. You don't need to do it. It's a check to make sure you didn't miss something and have something that's not quite right. So once we hit there, we're done with dirt. The dirt figures the width of the foundation. So this is all dirt down to here. Okay, the next one is loads. Okay. Then we're going to go concrete and steel. We've got her whipped. So loads, let's take a look at it. Determine the force with which the soil is pushing back up. So underneath here is dirt and it's pushing up. It's trying to hold this thing so it doesn't sink. And that's what we're going to do. That's letter I, or H, I. So let me go through. G was I. I want D. Okay, same as before. You've done this several times. D is the distance from the top to the middle of the bar. Okay? That looks like it's H minus half of a bar diameter minus cover. In my case, H is 18 inches. Bar diameters are number 5. Number 5 is 0.625 divided by 2. And cover, it's laying against dirt, so it's the 3 inches we just talked about. So there's my D. 18 minus 0.625 divided by 2 minus 3. 14.6875. I'm going to circle that. I need that number down the road. Okay? It's an important one. That gives me my D. I'll write it over here, 14 point, I'll put the arrow right there. 14.6875. I, J, H, H, I, H, I, excuse me. I, factored load. Remember, I told you a few minutes ago, when we're dealing with dirt, we don't factor the loads, 5,000 plus 7,000. When we're dealing with concrete and rebar, we do factor the loads. So it's 1.6 times 7,000 plus 1.2 times 5,000. And let me do this quick and see what we get. 1.6 times 7 plus 1.2 times 5. 17,200 pounds per foot. Okay. Oh, that got me through that one. And now I go to J, find the factored soil pressure actual. This is J. They call it PD. That's just the load factored divided by the width. And the width of the footer was 7 foot, so I've got 17.2 pounds per foot divided by 7 feet, 2457. I'm going to bubble this one too. I need that number. So this guy's pushing up with 2,457 pounds per square foot. Okay. Notice it's bigger than the 2,000. It is because it's a factored load. So now we've got ourselves in a position where we're going to start going into concrete. So critical section is taken. So letter K starts concrete. So I'm going to stop right here for a second and erase this and put concrete down. So our next grouping is concrete. And then the last grouping will be rebar or structural steel. Okay, we are right now at letter K. It says, determine the shear force VU on a plane a distance D from the face of the wall. Why D? Our 45-degree angle. So I'm going to use this picture right here, and I'm going to fill it in. D from the face of the wall. So this side is going to be shear. 14.6875. Okay, now the equations I got there are doing this. If you don't understand what I'm doing or you can't figure it out for some reason, you're going to have to default to the equation. Hopefully you can figure it out. It's not brain surgery, it's pretty simple. I've got 14.6875 here. I need, and here's my plane. That's the plane I'm worrying about cracking. It's actually at a 45-degree angle, but we just draw it vertically. Okay?